10, 20 is in the beginning, 30 is just above. And now we are at the stage where we can actually create the path and procedure. So we already have a main entry point. That's fine. And now we create another path, path 10, it's automatically name it like that one. And we just populate that with all the targets we made. And we put those here, drag them down like that. And then we have them in that order. And in the end, we should have target 30, which is just above the starting point, which is target 40. So we drag that one until the end. And then we drag 20 to the end and 10 to the end this way. And now we have a full set of targets in the path, and we right click on this one and we can check reachability, but we have to do a configuration. How will the robot move to each target point? So we do an auto configuration of all linear circular move instructions. So we get it to solve the configuration. It do it usually automatically. If it is in doubt, it will make a question. This seems to be okay as it is, and after that we can right click again and move along path, and it should show how it moves along the path. If we see something very strange, we can go and edit things, but we will see. If we have a near miss, okay, we just go to the simulation tab and resume. Now we stop this one because we get a lot of these. So we do like this, go to the layout, and we modify the collision set, or more likely we can open up the collision set instruction command and take away this pause stop simulation at collisions this way. Okay, close, and then we can continue. Okay. Move along path. So we start again. So now we can see how the robot is moving along the path that we created. We have changed the collision cue so it doesn't stop. It just makes an indication or a warning if it is near miss or at collision point. So we have some near miss warnings. We have collisions there, and the collisions are because it's not moving in a circular manner. We will fix that. And let it just stop there. Okay, so the next thing is actually to move over to the rapid language program editor. And that is done in a way that we have to synchronize this station to rapid, which is actually the controller. I click on everything. And in this way, it creates the program. So we open up the rapid container here, that one as well, and go to module 1, double click on that one. and we get the program for that path. And here we can see that we open up the rapid path editor as well. So what we can see here is actually the program going down. So we have target 20, target 30, which is just above, target 40, okay, that one okay, that one okay, that one, that one, that one seems to be fine. But here we should have a circular motion. So this starts it. And the next two define the circle, so to say. So what this means is that we should have a move C instead. So we do like this. We take move C instead. And that should be against target 120. And when we start to edit here, so we see how it should look like. So we have target circular point and target 2 point, which is in this case, target 130, like that. And in that way, we also saw that when this instruction was set, that turned into circle. It's fine. So the next one is actually the stop or the end point, but we can take it away by making it as a comment. So a comment is made by an exclamation mark. That's fine. And we had also a circle down here. So we just check what this is. It starts here. So that and that is the move circular. So change that to C, target 170, and target 180, like that one. So that should do the trick. And then comment out that one. So that's pretty fine. What we then can do right away, that now we move up, we increase the speed here to 1000, and we can have set 10, 50, 50. And that is the same here in the beginning. 1000, 1000, 1000, 50, 50, 50. Yeah, maybe 10. Okay, something like this. So now we should have a program that is more adapted to what we're going to see. And we make a apply all. Check the output here. No errors. Fine. If there was an error, that will be visible and we have to fix that. So, for example, if we made something error here and try to apply that one, there will be one syntax error, and that it would be indicated by the red here. So fix that again, apply all, and synchronize to the station. Otherwise, it won't populate back to the robot station. Synchronize that one. So every time we do something that we change in the station, we synchronize to rapid. When we do something in the rapid code, we synchronize back to the station. Otherwise, it won't be correct. Then we can run the simulation and see how it moves. Sorry, I forgot one thing. This path has to be put into the main entry point, so we drag it into that one. like that. And that has to be synchronized to the rapid code. Otherwise, we won't have anything. I will show you. So synchronize to rapid, like that one. It will include the main here. You see how it works like. And if we go to the rapid code and check the main module now, so we have a call to path 10, which is actually this one. Before we hadn't anything. Now we should be able to run the simulation. That one. But we have near misses, but we don't have any collisions. We can make a quick estimation of how close we are. We just go to the layout here, right click on this one, modify the collision queue, and change this to 1 millimeter, see how it runs. Would be of interest. So you see, I mean, it is in between 1 millimeter, 1.5 with near misses, which seems to be quite okay. If we now, for example, change in the rapid code for the module 1, we change the set value, for example, set 0 to set 1, find or replace set 0, comma, to set 1, comma, replace all, and then apply all. Just check that everything looks fine, no errors, good. And then go to the station, synchronize this, go to the simulation tab, run the simulation. Still works, good. If we look more closely here, we see some rounded corners coming up. We make it even more, like set 5, and we do place of Z1, comma, to Z5, comma, replace all, and synchronize the station. You can see here that it is rounded. Most likely there will be some indication of near misses, but not really. It seems to be working quite fine. And then we do set 5, comma, to set 10, comma, place all, like that one, apply all, no errors, synchronize station, run the simulation. Yeah, that is too much. So we see we have near miss all the time, but apparently it seems to be no collisions really, which is good. But and now when we've done that, we can actually also check a few things related to the cycle time. So start, stop, good. So if we do this, play this one here, so we can have an indication of what we are looking at when we had a set value of 10. 15.372 seconds. Now, I don't think it will change very much, but we can just have a look at it. If we change for set 10 to set 1, play all, play. And run that simulation. Now we have no near misses. Yeah, I mean, this is 15.732. We talk about 3-4 milliseconds, tenths of seconds more in time. What matters more is actually if we go take that down. If we change the velocity, that is actually what matters most. So if we change, for example, the velocity from 100, now there are of course limits how fast can you actually run something, and because the faster you run, the more overshoot or something happens with the controllers and so forth. But most likely we can easily run at 400 millimeter per second. That should be pretty okay, I think. And the 1000 could easily be 1500 here, or even 2000 from that point of view, down to a close target. And the same here when we move up, it could be 2000, 2000. Maximum velocities is around 2,500 millimeters per second. And this should be pretty okay. We can make an apply everything, check the output, no errors, and we synchronize to the station, and then you run the simulation. Goes pretty much faster, 5.52 seconds. So it's the third of what we done before. And we can change just to see how it reacts. We're changing the Z value, Z1 with Z5 seems to be pretty secure. Operation, apply all, just check the output, no errors. It's quite easy to get some errors sometimes. So synchronize everything and get that running. 5.52, we had that. See if there is any change. Yeah, I mean, we save 1.5 tenths of a second, something like that. So really, if it is time critical, one should look at the set value, but I mean, the velocity is always what matters most. So this, I would say, is about it. Then there are ways to create simulation movies. We'll take that later on, but basically at the simulation tab, we have recordings, record simulation, and things like that. Okay, bye for now.